Hello everyone. You're welcome back to my class. Here is the third day on the JAMB um, practice section. We've done question on question 1 down to 20. That is 2025. So we're going to continue from question 21 today. Question 21. If you now watch the question 1 to 20, make sure you watch that before you move to this particular session. So we're going to look at question 21. So question 21 says, uh, an object is placed 7 centimeter in front of a concave mirror of focal length 3.5 centimeter. The image will be A, virtual, erect and magnified, B, real, inverted and magnified, C, real, inverted and same size, D, virtual, erect and diminished. So before we can decide our question, our answer, and we have to look at do something as regard to the uh, mirror formula to get the image distance or image size, right? So remember that what is that our mirror formula? Here we're given that an object is placed 7 centimeter, so that is u. Is that correct? So that is u, the object distance, that is 7 centimeter, and the focal length of the mirror f is said to be 3.5 centimeter. So let's get the image distance v, which is equal to this unknown, right? So if we get this, so we can now use the mirror formula, 1 all over u plus 1 all over v equal to 1 all over f. So I have 1 all over u, which is 7, equal to plus 1 over v equal to 1 all over 3.5. So we're going to have 1 over v, which will be equal to 1 over v will be equal to 1 all over 3.5. Then this one cross the equality sign. It will change to minus 1 over 7. Is that understood? So assuming we don't have calculator, right? What do we do? So we can just change this one to a fraction by saying 1 over v equal to 1 all over 35 over 10. Is that correct? Minus 1 over 7. So I'm going to have 1 over v equal to, this is, take reciprocal of it, that's going to be 10 all over 35, then minus 1 over 7. So we can now do our normal fraction. Is that correct? If there's anything you don't understand here, it's a small mass. If I have 1 over 35 all over 10, this is a fraction on its own. So 1 over this fraction. So I can make 1 as a fraction by saying 1 over 1. Then all divided by 35 over 10. So that's the division of, it now become division of fraction by fraction. So I have 1 over 1. This bigger division turned to multiplication. The denominator become the numerator, and the numerator become the denominator. So I'll have 10 over 35. That's how I got that here. So coming here, I have 1 over v equal to, the LCM is 35. 35 in 35 is 1. 1 times 10 gives me 10. 7 in 35, that is 5. 5 times 1 gives me 5. That will be what? 5 all over 35. So I have 1 over v equal to 5 over 35. This implies that v will be equal to 35 all over 5. If you don't know what I did, you can just cross multiply, right? you need to be fast in your examination. So you can cross multiply, divide both sides by 5, you're going to have 35 over 5. So anytime you have 1 over x, for instance, equal to 7 over 2, x will be equal to 2 over 7. Take note of that, please. So come back to our work, which is v now is equal to 35 all over 5, which will give me 7 centimeter. You can see the image distance is the same thing as the object distance, 7 centimeter, 7 centimeter. So let me get the magnification now. Magnification M is image distance all over what? Object distance. That will be equal to 7 over 7, which is what? 1, isn't it? So since the magnification is 1, it shows that it's the same size as the what? As the object. The image size is the same as the size of the object. So one thing you need to know that for a concave mirror, it is only in one position, that is between principal focus, between, here is the pole, the principal focus, the curvature. So when the only position where concave mirror has a virtual image is when you place the object between the principal focus and the pole. The object is here. All other places, the image formed by concave mirror is always real inverted. So then it can be diminished, it can be same size, it can be, it can be magnified. So from what you have gotten here, you've already know that it's going to be real and it's going to be what? Inverted. Therefore, since it is this, it shows that it's the same size as the what? As the object. So therefore, the correct option here is option C. Real, inverted, and same size. I hope this is understood. So that is about question what? 21. So moving on to next question, which is question 22. Question 22 says, a student is viewing an object through a compound microscope. The distance between the objective and the eyepiece is increased. What happens to the final image? So what is a compound microscope? A compound microscope is a combination of two lenses, right? It's a combination of two convex lens, right? So one is said to be the objective lens, and the other is said to be eyepiece. So the objective lens is the one that is close to the object, while the eyepiece, which is also served as like a magnifier, right? It's like a magnified lens, right? So where the final image is formed, so it has a larger focal length, and this one has a relatively smaller focal length. So they are arranged in such a way to form what is known as a compound microscope. So the nature of the image form is always magnified and inverted. So when the two lenses, we have the objective, and we have this is just a rough sketch. You have the eyepiece. So we have the eyepiece and you have the objective lens. So here might be the object placed in front of the objective lens. So if possible, if you increase the distance between the objective lens and the eyepiece, then the image will be it will be very far away, and the final image will not be, or will no longer be in a particular focus for the observer. So that will be the effect of what? Of a larger distance between the objective lens and the eyepiece. So the correct answer here is option D, which is the final image is no longer in focus for the observer. I hope this is understood. So that is about question 22. Moving on to question 23. Question 23 says, a uniform electric field of 20 Newton per coulomb exists in the positive x direction. What is the potential difference between a point at x equal to 10 meter and a point at x equal to 5 meter? So we have this relation that uh, potential difference V is equal to negative of what? Negative of the product of electric field and the distance. Is that understood? So the negative here show the direction in electric potential. Uh, in this case, which is always decreasing. The direction of what electric potential is always decreasing, especially when it is in the same direction as that of electric field. Is that understood? So it decreases also along positive direction. So in this case, we have the first point is said to be x. Let's say x1 is 10 meter, and x2, the second point, is 5 meter. So there's going to be a change in potential. That is potential at x1 minus potential at what? x2 will be equal to minus electric field multiplied by the potential, the difference, which is x1 minus x2. I hope this is understood, right? So that change in potential is equal to minus change in the distance. So our change in potential will equal to minus 20 multiplied by the change, that is x1, which is 10, minus x2, which is 5. So that the change in V will be equal to minus 20 multiplied by 5, which will give us minus 100. So the 100 here, the negative here simply mean or show that there is a decrease in what? In the potential toward X direction. Are we together? So in an absolute value, this is going to be what? 100 volt. So the correct answer here is option D. I hope this is understood. So moving on to question 24. So question 24 says, a straight wire of mass 200 gram and length 1.5 meter carries a current of 2 amps. The wire is suspended in a uniform magnetic field in a way that the magnetic force exactly balances the gravitational force on the wire. The direction of the magnetic field is horizontal and perpendicular to the wire. What is the magnitude of the magnetic field or magnetic field strength, right? That is magnetic induction. So solution, you can just itemize what we have here. We have the mass to be equal to 200 gram, which is the same thing as a 0.2 kilogram, right? So in this situation, since other units are in their normal standard unit, make sure you convert gram to kilogram. So, and you're given that the length L is equal to 1.5 meter, and the current I is given to be 2 amp. I hope this is together, is taken. So, and we were told that there is a gravitational force, which we don't know. Gravitational force, right? Fg, which is said to be to balance the magnetic force, Fb. Let's take it like this, right? Or Fm, magnetic force. Let's put it Fm, magnetic force, and this is gravitational force. They said to be equal. So, and we asked to take G to be equal to 10 meter per second squared. And another thing that you need to understand here is that the magnetic direction, the direction of the magnetic field is horizontal and perpendicular to the wire. Are we together? So if it is like that, then we have our angle to be equal to 90 degree. So when you have itemized this, then you now come back to uh, this particular balancing. The gravitational force they are talking about here, since it was suspended, they are talking about the weight of the what? Of the wire. So that shows that Fg now is same thing as mass of the wire times acceleration due to gravity. Is that understood? And also the the magnetic force FB or FM is given to be BIL sine what? Sine theta. BIL sine theta. So when they are equal, it shows that mg will now be equal to BIL sine what? Theta. So we can make B subject to the formula. That is what we are looking for. Is equal to mg all over IL sine theta. So that will give us mg. M is already 0.2 multiplied by g, which is 10 in this case, all over I is 2 multiplied by L, which is 1.5, then multiplied by sine 90 degree. So that our B will now be equal to 2 all divided by 2 times 1.5. Sine 90 is something as 1. So I'm going to have 2 divided by 2 times 1.5. That should give us 3. That should give us 3. Therefore, B will be equal to, if we divide 2 by 3, it should give you 0. I think 0. 0.67 Tesla. 0.67 Tesla. But we don't have 0.67 here. What we have here is what we have. 5, I think they make use of 9.8 instead of 10. So in the exam, if you come across something like this, so since your answer is closer to this, just choose this and move on. Are we together? Especially when you know that what we have done is correct. Please take note of that. So our correct option here is option C. So that is about question 24. Moving on to question 25. Question 25 says, which of the following best describe the reason shadows form sharp edges under the direct sunlight? This is under rectilinear propagation of light. So light is absorbed by the object. Light is a particle. Light travels in a straight line. The object is opaque. So the answer is that light traveled in what? In a straight line. So it forms shadows, right? So that is about that is phenomenon of rectilinear propagation of light. That is formation of shadow, formation of eclipse, and what have you. So the correct answer here is option C. I hope we are together. So moving to question 26. The 26 says, two resistors R1. So we're given that R1 is what is a 30 ohms, and R2 is said to be what 6 ohms. They are connected in parallel. So these two resistors are connected in parallel. What should come to your mind first? Quickly, you just do side-by-side placement of the resistors. So that is parallel connection, side by side. So like this now, the two resistors are connected in what? In parallel. So here is R1, which is a 3 ohms, and here is a R2, which is a 6 ohms. This combination is then connected in series with a third resistor. So the whole of this is now connected in series with another resistor, R3, which is said to be what? 4 ohms. So R3 is equal to 4 ohms. So if a voltage of 20 volts is applied across the entire circuit, so then across the entire circuit, we have a voltage of 20 volts. So 20 volts is applied across. So what is the current flowing? So we're looking for the current I. So the first thing to do is to, find the effective resistance of these two resistors. What do we do? How do we achieve that? Remember that when resistors are in series, we find the equivalent. So let's let the equivalent be R1, 2. So it's going to be 1 over R1, 2 is equal to 1 over R1 plus 1 all over R2. So that here you have it to be 1 all over R1, 2 is equal to R1 is 3, 1 over 3 plus R2 is 1 over what? Over 6. So this we make our LCM to be 6. 3 in 6, 2. 2 times 1, 2. Plus 6 in 6, that is 1. 1 times 1 give us 1. Therefore, we have 1 over R1, comma 2 will be equal to 3 all over 6, which implies R1, comma 2 will be equal to 6 over 3, which will give us what? 2 ohms. Is that understood? So that our circuit now become, the whole of these two resistors become single. So quickly, the whole of the resistor become R1, comma 2, which is now equal to 2 ohms. Now connected to the R3, so here now is my R3, which is a 4 ohms. All of these connected to that my 20 volt. So my current is T here. So when resistors are in series, what do? We just sum them together. So the entire resistance of the whole circuit, R total, will now be equal to R1, comma 2 plus R3, which is equal to what? R2 plus 4 to give us a 6 ohms. So having gotten our R total, we now apply our Ohm's law, which is V equal to IR. From here, this implies that I will be equal to V all over what? R total. So V is 20. R total is what? 6. When we divide 20 by 6, that should give us a 3.33 amp. I hope this explanation is taken. So that is about question what? Question that is about question 26. About question 26. So moving on to the next question, which is question 27. So question 27 says, which of the following statement about magnetic field lines is incorrect? Is incorrect. So what is magnetic field line? It's an imaginary line, right? So, okay, sorry. Like something like this. For instance, if here is north, two bar magnet of different poles, like here is south. So here is the line of force, right? Right. So, so here is your line of force, magnetic line of force, right? Something like this. Something like this. Okay, just draw it anyhow. And it always emanates from positive, the north, and enter through the south. Something like this, right? So, so, so something like this. So here's your magnetic line of force. So which is incorrect? A, they always form closed loop, which is correct, to form a closed loop. They emerge from the North Pole and enter the South Pole, as I told you, that is correct. They intersect at point where the field are strong. They do not intersect. Their density represent their field strength. So how closely they are, that is the density, how dense it is. So the more closely the line of force, the more the strength of the magnetic field. So the only option that is wrong here is option what? Is option C, intersecting. They do not intersect. Are we together? So that's about question 27. So let's look at 28. 28 says, why is it easier to open a door by pushing at the edge furthest away from what? Farthest from the hinge. This is because when you do that, right? Let's look at option first. You have it reduce the effect of the door's mass. No, the friction at the hinge does not apply to it. It gives a larger or bigger moment. So to be easier, remember that moment is equal to force times what? Time distance. So if the distance is much, then you have bigger moment, which will be easy for the door to be opened. I hope that is understood. So moving on to question 29. So question 29 says, uh, a particle performs simple harmonic motion with an amplitude of 10 amps. So you have amplitude A is 10 centimeter rather. That will give us 0.1 meter. and a period of what? 2 seconds. So we have capital letter T, which is 2 seconds. What is the magnitude of its acceleration? A, right? Acceleration when its displacement from the equilibrium position is 6, that is x. So x is 6 centimeter. That will give us 0.06 meter. So please, most of this topic, I can't take it from the beginning. You can just go back to your this thing and read it. You'll be able to get or understand how the solution is being tackled. Is that understood? So the acceleration, the inward acceleration of a simple harmonic motion is given by A equal to negative omega square x. This is one of the characteristics of a simple harmonic motion, that the acceleration is always directed inward and always, proportional to the displacement, right? So this is that the negative shows that it is always inward and always in opposite direction to that of the displacement. So here we don't have our omega, but we know that omega is equal to what? 2 pi all over t. So this will give us 2 pi all over t, which was 2. Therefore, omega, this implies that omega is equal to what? Pi rad per second. So that is omega. So if I've gotten our omega, we can now come back to this formula for acceleration to input it. This will be equal to, or this implies that acceleration is equal to, remember the negative sign is just a sense of direction. So pi squared. So for the omega, we have pi squared multiplied by the displacement from the equilibrium position, which is 0.06. So what is our pi? So A is equal to 3.14 all squared, right? Multiplied by 0.06. So when you press your calculator, you should have when you press your calculator, you should have 0.59 as your answer. Just square this one multiplied by 0.06, have 0.59 meter per second squared. I hope this is understood. That is about question 29. And finally, for today's session, we're looking at question 30. So question 30 says that a wheel and axle has a wheel radius of 50 centimeter and axle radius of 10 centimeter. So the efficiency of the machine is 60%. What is the effort required to lift a load of 500 Newton? Remember that this topic is on a machine, right? Mechanical energy. So whenever you have this, remember that velocity ratio is peculiar to different uh, machine, right? So for a wheel and axle, the velocity ratio is equal to the radius of the wheel all over radius of the axle. So take note of this. So, and here we have the efficiency to be equal to 60%, right? And we're given that the load is equal to what? 500 Newton. Is that correct? So what else were we given? We are given the radius of the axle and radius of the wheel. So that will give us our velocity ratio. So remember the relationship, efficiency is equal to mechanical advantage all over what? Velocity ratio multiplied by 100%. What we are looking for here is effort, right? But before we can get effort, we need to get mechanical advantage, because mechanical advantage is where we have load all over effort. I hope this is understood. So that is why we need to get mechanical advantage from this relationship before we can apply it to get our effort. Is that clear? So now coming here, we need to get our velocity ratio for this particular machine, which is wheel and axle. So velocity ratio, as I told you, is equal to the radius of the wheel or radius of the axle. That will give us a 50 all over what? All over 10, which is equal to 5. Velocity ratio has no unit. Is that clear? So it is 5. So we can now come back to our our formula here and get our mechanical advantage. What is my efficiency? Efficiency is 60 equal to mechanical advantage. We don't know, all over velocity ratio, which is 5, multiplied by what? 100. So we can multiply, cross multiply, you're going to have mechanical advantage multiplied by 100 equal to 60 multiplied by what? 5. So that mechanical advantage will be equal to 60 multiplied by 5 all over what? 100. 0 cancel this 0. We have mechanical advantage will be equal to 5 here, 1, 5 in 10, 2, which will give us 6 all over 2. That will be 3. Mechanical advantage has no ratio, it's a force ratio, it has no unit as well. So having gotten mechanical advantage, we can now say mechanical advantage, which is equal to load all over effort. So here mechanical advantage is 3, and our load is said to be 500 all over the effort. Therefore, effort will be equal to what? 500, right? 500 divided by 3. So when you press your calculator, you should have 166.67 Newton. That is option what? That is option C. I hope this is understood. So we are going to stop here in today's class and continue from here in our next class. Please, if you have any concern, something you don't understand, please make sure you drop it in comment section and I'll get back to you. Thank you for your time. See you in the next class.